All right, welcome again. We're gonna do hashtag 4 in the arrays and the hashing section of need code 150, if I'm right. I think, I'm not sure where you start, but yeah, cool. So we're gonna do a medium problem group anagrams, and the code we're gonna do it in is in Python. And I guess we're gonna group the anagrams. Given an array of strings strs, group all anagrams together into substrings. Sublists, you may return the output in any order. Okay. Also, input strs, stack, pot, stop, scat, stop, hat. All of the possible of act, cat, hat. Yeah, doesn't have no stop, pots, stops. Equal to x, there's okay. Okay, so any and we can have some help here by checking out the pi. No, not Python. Let's search the cool one, which is the coolest. So I like this. I like this website. It's pretty clean. Uh, is it the same one? Yeah, it is the same one. But yeah, we're gonna check the valid anagram problem. So I guess we're just gonna refresh ourselves with the problem. Yeah, I should probably even bring my notepad this one. Notepad. And now that's the plan, bro? Okay, okay, and put a string, which is the function, we will group all the anagrams together to sublists that can be returned in any order. So I guess we can start from no, but yeah, let's figure it out. And if we can't figure out within 10 minutes, then we can check out the solution. Timer. We have so we're gonna try stuff. Okay, I guess we're gonna create what's the difference between this one? Well, this one is a self-constructor. Oh, no, it's the same. Except strs is now has a list of I still don't know what the hell this means. I guess it points toward this one. Ah, it's a function that produces this output. Okay, I guess, yeah. Yeah, I learned that from JavaScript. Pretty cool. But yeah. Anyways. So instead of this one, we're not gonna return true, but return a list. So when we get an input of strs, we're supposed to output a list. And I guess an idea of mine is a dictionary, but no, a dictionary won't work. Look, is this a list inside of a list? What the hell? I have no idea. Well, let's figure it out. So I'm gonna create uh, a sublist equals to an empty list, and I guess we're gonna return an array inside of the sublist in the channel. Yeah, bro. And let's see how guess we can also make a for I in range of stirs. But what's the idea here? I mean, we could uh, a notepad. Let's call it a notepad, bro. So, why do we need to do this? To make the list exact same, but make its colors be separated in a list, a sublist. Sublist that can be anagrammed. How do we do this? I have no idea, but let's figure it out. Maybe we can try for stir in stirs. We can try a loop in each stir. And if it has the same length, but no, that's not gonna work because we could possibly have this. We could also have we can create inner for loop for uh I in stir will will yeah, but yeah, I guess that's a pretty well, it's a pretty no for stir and stirs. I mean, yeah, it's a pretty smart idea, and we'll so that we can like check the values. We can create a hash map. Throw a hash map at it. This that's the funny, or I think that's the correct answer. Is this hash map? This is a dictionary though. I don't know. Okay. We, okay, let's a draft. We can try a hash set or a hash map. I don't know what the hell is a hash set or a hash map, anyways. What's the difference between a hash set and a hash map? And so am I being heard? Yeah, wait, am I being heard? Hash map stores elements in key value pair. Or it's only objects. What the hell is an object? I haven't figured that out, bro. All I know is a hash map is a map that uses a hash table. So it's more, I know, since hash tables are like an array and then ends with linked list. What's the hell's the a hash map is has a map that for each hash, I don't know. Well, a hash set is a set that also employs a hash table for storage. Okay, it also uses hash tables. So, hash. Uh, I have no idea what the heck I'm talking about. Checker equals an empty dictionary. Is this even a hash? I don't know. Hash. What do we do? I don't know how to code it. What to code or how or why. Okay. It's fine. We can figure it out. So for stir and stirs, now we're iterating over the stirs. We can see, we can check, we can put this, we can also ask for S in stir as well. But that's stupid. That's stupid though. Like you're iterating each stir and then you're also iterating each S in stir for stirs. No, it's gonna go here first before it goes to the next stir. We're gonna index, we're gonna start from the range of 0 to length of the stir, and then we can put them in a hash map or a hash set in which we can which we can then after that we can then compare it or something. Compare it. The next step is after we put them in, let's theoretically, I know how to put them in a hash map or hash set. We can then, we can then like, uh, group them. We can group them. But I don't know. We can then group. No, not group based on their given sets. Maybe. Okay, let's just try it. So for it back in there, put S in the range of 0 to length of the oh no +1. And then put S dot and no not S dot and S dot add checker. S dot on check. And this is hell is freaking wrong. And no, it's supposed to be add though. Oh no, but what else can we try to figure out? Well, we can ask, I know, for some hints. Instead of checking the solution, we can check. So we can ask DDB. Let's try to explain. No, no, instead of giving the code, let's try to explain my code instead so that you can see what's wrong with mine. Instead of giving me like a bare bones solution. Okay, buffer. What's this live share? ADDB and trying to solve a problem is to group each anagram based on this. So my initial guess is first create a result which list and then maybe make a for loop and put them a hash map or set comparison. What's your idea? Oh no. Okay, fine. That's a solution for the first example. Now reducing a hash map to group anagrams. Here's a general idea to help you. Initialize a dictionary. It's this a dictionary. Oh, let's go. Okay, it's a dictionary. Straight to wishes. I had an idea for that one, but I think my syntax here is wrong. So s- should be using the diction. I screw you, dude. I'm checking the solution. Okay, okay, okay. Oh yeah, the default diction. Oh my god. Ah, the hell. Okay, it's just a default dictionary which has lists inside of it. Oh, huh? Wait, let me ask this too. Oh, I did this. This one creating dictionary in which has lists. Oh, okay. What else can I use with default dict? Can I use int? Oh, so that's the use of that function. That's cool. Uh, so you can say what? Uh, I learned to accept school. Okay, let's go. Let's keep going. So this one, oh my gosh. See, I told you, dude. For C instead, this is the one. What? For each character instead. I think that's more smarter. But yeah, let's watch.
Hey everyone,
Yeah, I'll watch the
welcome
video.
back and let's write some more neat code today. So today let's look at a good question to practice the fundamentals, group anagrams. So we're
What
given
the frick?
just a list of strings and we want to group all anagrams together. So for example, we have tan and we have nat and they are anagrams together. So
Yes.
in the
So they
output, we're
should.
going to group them together into
They should be
one
grouped.
sublist. And how do we know these two are anagrams of each other?
They
The
have the
first one
same.
is tan, the second one is nat, and you see if we swap
They have the
the
same
N
length,
and the
and they have
T,
the
then
same letters
we get
used.
tan,
Oh,
right?
wait,
And
hold up.
that's the same as this. So by rearranging the characters, we can get equivalent strings. So these two are equal.
So this one creates count, a counter which is index 0 times 20. If it's index 0 times 26, it's gonna go to index 0, right? But this is, I maybe we can explain. What does this do? It's often used to count figures. Oh, okay, so it creates a list. Why not? Why not? Or, oh, yeah, I think that's wrong because it's gonna make a list of 26, a single element that is 26. Okay, okay. Yeah, I know that was wrong, but yeah, let's keep going.
So another way of looking at it is two strings are anagrams of each other if we take each of them and sort them, right? So if we sort
Yes.
both of these, we're going to get ant, right? For both of them because that's the
Oh,
sorted version. So if they're anagrams of each other,
where the function, sorting function. Oh, wait. So this one, for each character in the string, you count it, you give it a space up in the inside the list from the order of the character inside the string or the s stir. Let's just say stir since to make it not confusing for me. So this is stirs, this is a stir, and then this is s. So s stirs, stir. It goes stir, then stir, s. Okay. Aha. Okay, thank you. And then he minus the default lowercase, but doesn't it mean there's a tuple as well? The heck? I'm not used to the tuple, but we ah since it's a tuple, it can take it as two values instead of one, right? And then you add it to one. A calculus minus one calculus. And it seems there's no ano here, capital letters, assuming that
time
ano.
complexity. So my question is, can we do strings? So that's how much it takes to sort them, right? So if we sort both of these, we're gonna get ant, right? For both of them, because
Yeah,
that's the sorted version. So if they're
but that's gonna
anagrams of
take
each
long.
other, when they are sorted, they should be equal, right? So one way to group anagrams together would be to take each one of these strings in the input and then sort them.
I
But the
can't believe I
time
haven't thought of
complexity
that.
of that is going to be n log n, where let's just say n is the average length of each of the input strings. So that's how much it takes to sort each of the strings, and we have to do that m times where, let's say, m is the length
length.
of how many, like basically how many input strings were given in the first place. So you can see
Yeah,
that
because you
this
have
is
to
going to be
order
the
them
overall
all
time
one by one.
complexity. So my question is, can we do better than this? And actually, the
Yes, you
simple
gave me the
solution in
answer.
this case happens to be more efficient, and let me show you that solution right now. So one also condition that we're given is that each character is going to be from lowercase a to lowercase z. So at
Okay.
most we have 26 unique characters, right? So let's just have an array called count. So for each one of these strings, we want to count the characters from A to Z, right? How many does it have of each? So we know it has one E, one A, and it has one T. And for this one, we would see that the exact same thing is true. It has one E, one A, and one T. So if we use a data structure called a hash map in this case, and in this case, our key is going to be this over here. So this is what we can use to identify anagrams, and then our value is going to be the list of anagrams. So in this case, how many strings or which strings have this pattern of count, 1E, 1A, and 1T? Well, we see there's one eat, there's one T, and there's one last one, 8. So those are going to be the values. We'll have a list of them, eat, T, and then 8, right? So we'll have 3 strings, and as you can see in the output, it's a little messy, but that's what we have here, right? So these 3 are grouped together, so we're going to use a hash map to group them together. Since we're using a hash map and all we're doing is counting the characters of each, and we know that we have a limit of 26 lowercase characters, the overall time complexity is going to be big O of m, where m is the total number of input strings that were given, times n, where n is the average length of a string, because we have to count how many of each character it has. So we're going to have to go through every single character in a string. And since we are using count, right, or this array in our hash map, we're using it as a key in our hash map, we kind of also have to multiply this by 26 because that's what's going to be the length of our count array. But you know that this reduces anyway, so the actual time complexity is big O m times n. So now let's code it up. As you can see though, this is basically one of those problems that can be solved with a hash map very efficiently. Wow. So let's create our hash map. We'll call it result. And so remember what we're doing is we're mapping the character count of each string, and we're mapping that to the list of anagrams. So to do that, we of course have to go through every string that we're given in the input. And we want to count how many of each character it has. So we'll have initially a array. So we're going to have 0 in it, and we're going to have 26 zeros, right? Because one for each character. So from lowercase a all the way to lowercase z. And now we want to go through every single character in each string, and we want to count how many of each character. So we want to map, in this case, A to index 0, and we want to map Z to index 25. So how can we do that? Well, we can, one way at least, is just take the ASCII value of the current character we're at, C, and then subtract the ASCII value of lowercase character a. So as you can see, lowercase a minus lowercase a is going to be 0. Z, lowercase z minus lowercase a is going to be 25. So we do have it correctly because, for example, let's just say a is ASCII value 80, and I don't know if this is actually correct, but it's just a random value. Then b is going to be ASCII value 81, and so on. But if we want to map this to 0, we know one way to do that is take 80 minus 80. If we want to map lowercase b to 1, we can take 81 minus 80, right? So that's basically what I'm doing here. in case you haven't seen something like this before. And so we're just going to increment this by 1. We're just counting how many of each character we have. And now in our
Ah,
result,
so you add a value of 1. Hmm. Let me ask how this thing. Okay,
we
but yeah,
want to
we'll try it
add, so
first.
for this particular count, we want to
Rest of the bit.
we're going to append this string s. So we want to group all anagrams with this particular
So this one becomes index 0. You add a value of 1 to the index 0. I'm right?
count together.
That's
Now,
AI
what
for
if
this.
this count does not exist yet? Well, I'm actually going to change this dictionary to a
Default.
default dictionary or a default hash map where the default value is a list so we don't have to deal with one edge case. And also, right now our count is a list, but we know in Python lists cannot be keys, so we're actually just going to change this to a tuple
See,
because tuples are going to change this to, so
right?
we're actually just going to change this. Lists cannot be keys,
At
so we're
least
actually just going to
lists
change this
cannot be
to a
keys.
tuple
Tuple.
because tuples are non-mutable. But mainly
Ay,
this is Python
non-mutable.
stuff. You might not
Mutable.
have to
Gusto
worry
ko na
about this
titigil.
in other languages. And so that's actually it. So now
Oh,
in our dictionary, we have grouped the anagrams together, so we just can take result.values. We don't want the keys anymore. We just want to return the values, the anagrams grouped together, so we can return that, and we're actually finished. So this is the optimal m times n
does this one
solution,
use that
where m
values? Oh yeah.
is the number of strings we're given,
Okay, cool. Good
and
first.
n is the average length of each string, how many characters are in each string. So I hope this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll
Yeah.
hopefully
I
see you
like.
pretty soon.
Never mind. I think I understand now. I did not remember anything. Okay, so great. An empty list. Give it an index of 26. Yeah, 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 yeah. No. That's count. So count. So we're gonna give it 26 possible arrays or values to be stored depending on the letter so that it accommodates everything. Plus X 26. Oh yeah, should it be count? No. Let's make 0. It's 26. So this one gives it 26 slots for the array. Then for C in stir, we're gonna get count. And then inside of that count, we get the ordinal value of the current C. Yeah, that's correct. Yeah, that's correct. C minus the ordinal value of lowercase a. So as Neat Code said, we're gonna minus that 80 minus 80. Oh no, 65 minus 65 so that it will have index 0. This will be like instead of and then you apply a value of 1 to it so that so if it goes index 0, oh that must be a. So we add 1 to this index 0 so that has a value of 1. So then we can then compare that in which it will find that that's correct. And after that, uh, we're gonna have to create a tuple, if I'm right, in which count inside of the count you put the yeah. Oh, you put the answer, not that up. So ans answer is a pretty confusing. I know, but yeah, I can't. I know, can't really memorize the syntax as that tuple dot count. Yeah, so that tuple. Because this cannot be values. You have to put this inside of a, so that you can't, because a tuple cannot be stopped. You'll take anything, and a list wouldn't let it be a key. So tuples are better. And then after this, well, Frick.
Hey everyone. Group all anagram.
Okay, we append it. Oh my god, why am I dot append? No, 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 no. So we're gonna append stir. See, look. So basically, on my ano, you're gonna stop the for loop first, alright? You're gonna get the counters first, and then after we get the counters, the total amount, we're gonna get the answer. Inside of this will be a tuple, and you append that to each stir on what's the value. This is the count. Look, count of the answer. And then you append that to the stir. Or I don't sure as hell don't know. I'm just bullshitting. Return as dot values. There's the values of the list. And it should work. And there's should probably something wrong with this. Oh, yeah, this one is not. Okay, we're good. Still probably still up. Let's go. Anyways, I'd like for some questions with this one. I have a question. I'm quite confused with the append function after getting the value in each letter. How does it work? The append function adds the string to the list corresponding to the key. Okay, so it corresponds to the. Oh, okay, so it's kind of group. It's still confusing because it's abstracted. I can't see what the hell's happening behind the scenes. But basically on what DDB said, you append the stir in which the answer in which so the append stir tends it to a couple corresponding to the count. Yeah, but how does the computer know code how to go through the correct couple count? Sir, I am quite confused. I basically it knows that the benefits. Okay, fine. I'm gonna answer more questions. Thank you for watching.